Good day everyone. I am Mark Angelo Argalandes and I will be discussing about our 8th topic on histopathologic and cytologic techniques laboratory, and this will be our first topic for finals term, which will be all about sectioning. So here are our learning objectives. Identify the types and parts of a microtome, name the types of knives used in microtomy, appreciate the significance of accurate cutting of tissue sections, enumerate faults that may occur, and identify the probable cause, provide remedies for troubleshooting faults, perform the technique properly. So for this pre-lab discussion, we will primarily be focusing on the types of microtome and particularly the rotary microtome and how it is being used in sectioning. However, it is important to take note that majority and the bulk of the discussion associated with sectioning, trimming, and microtomy will be part of your lecture's discussion. So first of all, let's define sectioning. Sectioning is also known as microtomy or cutting, wherein it is the process that involves tissue that are being cut into uniformly thin slices to facilitate microscopic studies. And, as its name suggests, the instrument that is being used is the microtome. And the image here on the right is what we refer to as the rotary microtome, commonly used in routine histopathologic laboratories. Sectioning is also performed after trimming of the specimen. So ano ba yung difference ng trimming and sectioning? Trimming often cuts the tissue block but not necessarily the tissue embedded into the tissue block, whereas sectioning cuts off a unicellular surface of the embedded tissue, or not necessarily unicellular but into thin slices, typically around 5 to 10 microns. Depende kung ano yung embedding medium na gigamit. Okay? The mechanism involved in sectioning requires the slow movement of the block into the path of an extremely sharp knife. So, in the case of a rotary microtome, yung blocks po ang gumagalaw papunta sa sharp edge of the knife. However, this is not the case in all other types of microtome. An example of which is the sliding microtome, wherein the exposed blade is the one that is moving towards the tissue block. Again, in a rotary microtome, which is the one that we used in our laboratory, it is the tissue block that comes into contact into the sharp surface of the knife. So what are the microtome knives? Generally, they can be grouped as the standard thick metal, the thin disposable blades, and the glass knives or diamond knives. So, ang standard thick metal, it allows sharpening. So, pwede siya, ginagamit natin siya sa stropping techniques, yung pwede natin siya i-polish, pwede natin siya ibaid, basically. So, in your lecture, you will find out na there are different, meron palang iba-iba na mga baid or mga hones that we can use to sharpen standard thick metal knives. However, these are not typically employed in a routine histopathologic laboratory in modern times. Then, you also have your thin disposable blades. So same with or even better than standard thick metal, and it is relatively cheaper. Yung appearance ng thin disposable blades is actually similar yung sa cutter or the X-Acto knife. Ang napakaganda kasi sa thin disposable blades is that you no longer have to sharpen disposable blades. Kasi typically after use, or after a certain usage, then you can easily discard it and replace it with new disposable blades. Kaya better siya and cheaper siya than standard thick metal knives. Then you also have your glass knives or diamond knives. So they are used for plastic embedded tissues such as those embedded in methacrylate, araldite, or epon. So for glass, pwede siya mag-cut up to 1 micron thick, so that's very thin. Whereas yung diamond naman, it is used for electron microscopy to get ultra thin sections that is around 0.25 microns. So that's basically the thinnest section that we could achieve using the diamond knives. Asan siya ginagamit? For ultra microtomes. Okay? Now, in order for us to gain good sections and good ribbons, we need to make sure that we could achieve the appropriate knife angle. So, in general principle, excessive bending of section at the cut line is disadvantageous. Errors happen if knife angle is too shallow or too steep. This damages the specimen. So, similar in principle, if you're going to make your blood smear, the angle of the knife, in contrast to the angle of the block, really has an impact in terms of the quality of the sections. Nagte-tear ba siya? Or does it form good ribbons? Or is it too thick or too thin? All of those are actually factors of the knife angle. So here are the rules. Position the lower bevel face parallel to the specimen block and plane of motion. Raise the angle slightly above the bevel angle. This is to avoid having the lower bevel face slide over the specimen block and cause friction damage. This correct knife angle positioning should be consistent regardless of the type of microtome of the specimen. For this slide, I want you to be able to be familiar with the terms clearance and bevel angles because this is often asked in the board examinations. So, clearance angle, it prevents contact between the knife facet and the face of block. And for rotary microtome, it is typically at around 0 degrees to 15 degrees, whereas the bevel angle, also referred to as the facet, is the angle between the two facets that form the cutting edge. So knives and disposable blades already typically has a range of 35-degree angle. So to better understand, let's look at the diagram. You have here your clearance angle. Ito po yung clearance angle natin. Again, yung clearance angle, it prevents contact of the blade and the surface of the tissue block. Whereas ang bevel angle, this is the knife. Ito yung knife, no? Yung angle made by this facet and this facet is what we refer to as the bevel angle. Now, perpendicular to the tissue block against the front facet of the blade is what we refer to as the rake angle. Again, clearance angle is from the bottom facet perpendicular to the surface of the tissue block. Then you also have your bevel angle, which is the angle formed by the front facet and the back facet of the blade, of which typically it has a variable range at 35-degree angle. And lastly, you have your rake angle, which is the angle formed by the vertical axis of the tissue block against the front facet of the blade. Yun yung tinatawag natin na rake angle. So this is another way to demonstrate the angles. So ito yung clearance angle that is perpendicular to the surface of the specimen. And in this case naman, if you go to the half of your bevel angle, if half ng bevel angle nyo is perpendicular to the tissue, then nagkakaroon tayo ng problema because there would be no ribboning. Or if there are ribbons, pangit yung napaproduce. And then another, if yung clearance angle nyo is too steep and masyadong manipis ang inyong rake angle, then ang tendency is you're just going to push the specimen block out of the cassette holder. Yun yung nagiging problema. So again, ideally, the clearance angle should be around 0 to 15 degrees, whereas the bevel angle is typically 35 degrees. So here are the considerations. Incorrect knife angle have various consequences depending on the specimen type, fixation and processing qualities, and the knife flexibility. So this is taken from Richards but modified on the year 1959. So if the ribbon is crooked instead of straight, then upper and lower edges of the block face are not parallel to each other or to the knife edge. Knife may be uneven, so you should try another section of the knife edge. This recommendation is typically associated with disposable knives because you could just adjust the area kung asan sa disposable knives ang gagamitin nyo na cutting edge against the surface of the tissue block. Ribbon does not form and each section comes off separately. Remember that when you're performing sectioning, you should get ribbons of the surface of the tissue and not just one isolated ribbon. So this could be due to the blade edge being dull, the knife being the wrong tilt, and upper and lower edges of the paraffin block face are crumbled or rounded. So ang pwede natin gagawin is if dull siya, then of course you should sharpen it with a hone and perform appropriate stropping technique after. Knife was in the wrong tilt, then simply just adjust the clearance angle. Upper and lower edges of the paraffin block face are crumbled or rounded. We could retrim with a razor blade. So you're just going to trim the surface of the tissue block to better expose the tissue. Sections are compressed or folded. It could be due to the knife being dull, the angle too close to the vertical plane, the knife is clogged with paraffin, and sections are too thin. So if the knife is dull, again, you just sharpen it with a hone and then perform appropriate stropping procedures. Knife angle is too close to the vertical plane, then just increase the angle or the rake angle para mas magbaba ang clearance angle ng knife. Knife is clogged with paraffin, simply clean the edge with chloroform or even xylene. Then, sections are too thin. Simply increase the thickness because in a rotary microtome, the thickness of the section could be adjusted. So yun lang. Just adjust the thickness of the microtome. Sections are compressed or folded. It could be due to the paraffin is too soft because the room is warm or the paraffin is still contaminated with xylene. Remember that xylene is able to melt paraffin. That is why it could be na soft siya. Because the paraffin block is soft due to contamination with xylene, then you should perform the re-embedding to completely remove the xylene prior to infiltration. Then, if the paraffin is too soft because the room is warm, simply pack the blade or tissue block with ice cubes para malamig ang block, malamig ang knife, then you could prevent melting. If the specimen crumbles or falls out of the paraffin section, it could be due to the following reasons. It could be inadequately dehydrated or cleared. So in such cases, you should just dissolve the paraffin, rehydrate, and clear again. So if the tissue is too hard and compact, such as the liver, then soak in water or 70% ethanol to soften. So if you've noticed, diba, compact ang liver. So we just have to hydrate the tissue para maging softer siya. Tissue was in the paraffin oven too long or too high a heat. Remember that tissues are proteins, and with increased temperature, what happens? Denaturation. So there's really nothing left for you to do other than discarding the tissue. Tissue is too hard for paraffin matrix, such as the bones or the cuticles. So you should opt for the celloidine method. However, the celloidine method does generate a thicker section as opposed to paraffin sections. Again, tissue blocks should be properly fixed and embedded because if not, it may result to tearing, ripping, holes, and folding. Ribbon continuously splits or scratches vertically. This could be caused by the presence of crystals or dirt particles which are caught on the knife edge or on the paraffin face. So if madumi yung blade mo, then you might have a tendency na magisi yung ribbon mo vertically. And if the knife edge is nicked, ibig sabihin hindi na hone properly or hindi na na-strobe properly, then meron ng mga bumps and crevices in the knife that may form tears and scratches of the ribbon. So, use another section of the knife or sharpen it appropriately. The ribbon wraps itself around your finger, the knife blade, or anything else. So the problem is static electricity, which is often present in very dry rooms. Knowing that this is present in dry rooms, simply hydrate the room. Paano? Let boiling water stand nearby and section in the morning hours or just make short ribbons. This is to maintain humidity, which can be helpful in certain conditions, especially when there is increased static electricity. So these are the general steps for microtomy or sectioning. So for the complete reference for the procedure, just refer to the lab manual. And finally, when finished with the microtome, remove the microtome blade and put it in its box. This is to prevent accidents. So what if nakat mo ang sarili mo? Remember that you're handling potentially infectious substances. Then clean up the wax around the microtome. You could use silene, but the manufacturer would use the WD-40 and put away all the instruments. So that covers sectioning, and that covers the eighth topic of our histopathologic and cytologic techniques laboratory for finals. Thank you for listening.